Now let's talk about path tracing settings. We will create again lazy profile, but for the path tracing right now. And after that, we will jump into proper like post-production pipeline with the color profile creation, additional passes for the render, and so on. So first, what you have to do before you jump into rendering with the path tracing, you need to enable reference depth of field. So for example, if you create a cinematic camera, and let's look through this camera for now, like this, and go into path tracing mode, you will notice that there's something happens if I, for example, change the focus of this camera. Let's change focus because right now it's set to 10,000 or something. So if I go to some lower values and try to focus on the car, for example, and with the reference depth of field, we'll have proper. You see, it's like kind of blurred right now. So it's looking weird, right? So white is blurred inside the glass, but with the reference depth of field, you have the proper, under the glass reflections, and that looks properly. Because for some reason, if it is disabled, see, it just like happens like really strangely. I just find this behavior strange, and look, it should not be looking like that. So if you enable reference depth of field, you have the proper glass working, and what is inside is not blurred. Look at this. Why it is blurred? That's the question, right? So, and when you're looking like this, especially, you can notice the difference if you change this to reference depth of field. Usually you don't have this one, but that also can be caused by the problem of the material. So you need to check with your material. If you click on the glass, open the glass material and go to master material. Here in translucency settings, you should set this translucency path before DOF, and that will be fixing this issue, because that issue can also happen in Lumen. So if we look like right now and change it to after again, there is like something happens, it just like doesn't work. And if your camera is out of focus, sometimes it can do weird things with the glass, and the glass is not blurred while the rest of everything is blurred, but the glass is not, or like opposite, everything is in focus and the glass is blurred. So that's what you should do with the settings of the material. That should be set to before DOF depth of field. So in path tracing it also works this way, but in path tracing, as I said, you should enable reference depth of field. Also, there is one thing with the reference atmosphere. Do not use reference atmosphere when you are using your main source of light as HDRI. There is a reason for that. So basically what it does, when you have the reference atmosphere, Unreal will use the sky atmosphere, this one, for like lighting and like for the field light or sky light. So if I set the reference atmosphere, see, it just doesn't care now about the HDRI, and you don't see any like HDRI reflections. What you see actually is the atmosphere reflection. So if I hide HDRI right now, you will see this is atmosphere and this is the reflection on the glass of the atmosphere. So if you are using default skylight, directional light, which you have in Unreal, use this reference atmosphere. Otherwise, like, you will not have this bleed color from the skylight, and it just gives some realism when you're using the sky atmosphere. See how much better it looks. You have this proper reflections. But for our purpose currently, we don't need that, because our actually HDRI having the skylight, which is actually like affecting and given this bleed color, and basically the color of HDRI is applied and all of the reflections are applied in that case. So let's delete this camera too, and let's jump into our main camera and let's set up our render profile. But before we do that, I would like to point out some flaw which you may have noticed already, or maybe you did not. But as you can see, when I use this mode, there is something strange on the wheels. And if I come closer, you can see that there is some light bouncing on the wheel, and this is weird. That should not be like that. And this is our plane. But even if I hide our plane, right, on which the car stands, as I said, like to support the car standing on the proper position on the HDRI, you will see that HDRI, because the nature of it is still emissive, it will cast some light on our wheels, which is like super strange, and in the end you will have the look like the car is floating. It's not standing on the HDRI. And for that reason, what I like to do, usually I just make this plane the size of the car, and I like to apply some black non-reflective material with like zero roughness or like completely rough material. You can create yourself such kind of material, but there is already a material which is anodized metal in automotive material pack. It's completely like not rough, and when you put it, see the difference. Like you can immediately notice that if I right now it's there, now it's not. And also the thing that your plane should be, as you see, like it's still reflected, right? This is like super strange. Why it is so, right? Because it still lets this bounce of light from the plane still, bounce it through the HDRI, which is like super like weird, and we don't want that. So what I do, I apply this material and just like make this plane basically the size of the car, so we don't have any like parasite reflection, and this is just it. And it looks already cool. Okay, let's create the profile now. So we go to Windows, Cinematics, Movie Render Queue, and add our HDRI. And let's create the config. Let's keep the JPEG right now. We'll delete the deferred rendering. We'll add path tracer, console variables, which we'll talk a little bit later. And basically, we don't need game overrides for that because path tracing uses zero loads all the time, so it doesn't care about that. And basically we don't need anything. We will do the color profile later, as I said, with all other additional passes, but for now this is the basic setup which you need: the path tracer, console variables, and anti-aliasing. So the nature of path tracing, that it needs more samples to accumulate the motion blur and basically make less noisy image. Path tracer is unbiased rendering, like compared to Lumen, for example, or ray tracing, which are biased renders. This is unbiased render and basically brute force, right? There are some updates in 5.4 that it makes path tracing to give less bounces for less detailed objects and so on, just to optimize it, but by default it's basically like a brute force. So for spatial sample count, you can use like, at least you need 512, I guess, or otherwise the renders come up really noisy, and the more light sources, more fog and details you have in the scene, the more time it will take to render. This scene is quite simple because HDRI is just a picture, it's one source of light, there's one car. That should render probably the same speed as Lumen. Well, basically on my 4090 is almost the same, right? I can't tell that on other systems how much of the difference that would be. So sorry, I just like getting dragged away. By default, you may see that in a lot of videos on YouTube, you see that they tell you to use 32 by 32 samples. That is, well, that is acceptable result, but I found out the best number and amount of samples. So I want you to promise me that you will take it with you to the grave. So the rule of thumb is that you need to use temporal sample count. It should be spatial sample count multiplied by 64. So 64 times of spatial count. This is it. So 4 by 256, and in total we get 1024 samples. And right now you'll see on the screen what is the difference. The thing is, when you're using 32 by 32, you will get your wheel like blurred much more, even though we have our 24 FPS sequence, we have shutter speed set up to 48, and we have our motion blur and post-processing volume set to 24. And even in that case, in the target FPS 24. And even in that case, you will get a lot of motion blur, and your wheel, especially if the car drives on the slow speeds, you will see that your wheel is like too much over blurred, and at some point it can just become, you know, the metal plate, just like flat metal plate, and you don't see the shape of the rim, and most of the times you want it. And especially during like slow paced videos, you would probably need this amount of sample count, this ratio, to get the best motion blur on the rims. And compared to 32 by 32, you will still see the rim shape, and you will not have this over motion blurred picture, which is like just unrealistic. So again, we will need to override anti-aliasing, and in past tracing settings, use always reference motion blur. Use it all the time, because first of all, it is faster, and second, the denoising profile works better. Basically, it creates the denoising profile when samples are collected and denoised afterwards, instead of denoising each sample count, which like just creates a mush out of our frame. And I will show you right now what is the difference. So let's see, it was 6 to 7. This is basically our one frame, and this is our lazy path tracing setup. You can always add Apple ProRes and just disable that. So you'll have, like, for stills you have JPEG, and for videos you have Apple ProRes, and you can just disable and enable that one, and save the preset. That would be path tracing lazy. Okay, accept. And let's hit render. As I said, first we will do with the reference motion blur, and then without. So I'll hit render local, and we have one, all beautiful, all go, and we will have a nice motion blur. And basically you can already see the picture, how that will look like, and that will look absolutely fantastic. Okay, cool. Right now let's disable reference motion blur, and let's have a look again how it looks like. First of all, this one is blurred. It's trying to denoise, you know, parts of this environment, and it goes really slower. Have you seen the difference, like with the time, how fast it was with the reference motion blur and how terrible it looks? See, all of the parts, it just like tries to denoise like all of those parts, and it just, well, that would be terrible. I even don't want to, you know, wait until it's finished, because I can guarantee you that is terrible, and you always need to use reference motion blur. Always. That's just like the main rule you need to have. Okay, next thing, console variables for path tracing. What I told you already about, that we have some problems with the nanites, and there are some things which can actually fix that really easy. So this one, let's see if it has nanite. Okay, let's drop this one into the scene. So it looks gorgeous, it has a lot of details and stuff like that, but as soon as we drop into path tracing, we see this like number of 3 triangles at max, so 3 polygons at max. And to fix that, we can use the console variable R ray tracing, nanite mode 1. And please don't listen to those people who tell you that you need to go there and like change this relative error and set the relative error to 0. This is just like super strange, because there is a dedicated console variable just for this purpose. So we can enable all your nanite meshes rendering in path tracing, and with literally almost to none issues with the performance, and it will not affect your performance almost at all. So for this one, we need to add this console variable to our render setup. Just the thing is that we don't need actually any console variables for that one, but I'll give you the ones which I'm using for path tracing. So console variable, this one, R ray tracing nanite mode 1, and we set it to 1. The next thing is if you have, for example, automatic landscape material which scatters based on the layer, it scatters some grass or rocks or something like that based on the material, and it has a lot of that, and just like puts all of them here, and you have all the vegetation in the scene just like we have on this HDRI, and that will not work in path tracing by default. You also need to hit a console variable for that one, and this is our ray tracing geometry landscape grass, and you should set it to 1 so it will enable the landscape material grass on the landscape, and it will be present. Also, you need to disable completely the distance culling. For that should be our ray tracing, again geometry instance static meshes culling, and that should be 0. Obviously we don't have any of those things here, but it's just for you to know. And when you create the profile, you obviously can put those console variables here, but they are only efficient while your project is running. And if you close and open the project, they will just reset to its default value, which you need to add otherwise in game or engine.ini file, which is located in the project directory. And with adding those into your profile here, that would be a really nice thing to have here. Also, this is it. You can disable denoiser if you don't like the denoiser. So R path tracing denoiser and set it to 0. Let's just disable all of those, accept, and without denoiser that will be a little bit faster. But when I work with denoiser, I just make the render of the test frame, right, and see, hey, it looks good with denoiser. If it is, then I just keep it rendered with denoiser. But sometimes the denoiser deletes or like cleans up a lot of details which I would like to see in the scene, maybe some sparks, maybe some other reflections, or maybe flakes on the car paint. I disable denoiser and just increase the amount of samples here, so it will have more samples, less noise, and it will not lose the details such as like car paint flakes. So right now we can render that one and see how faster it is. Like, amazing. It's blazing fast. It renders almost at the same speed as Lumen, if Lumen had the same amount of samples. So this one was without denoiser, and basically this is it for path tracing setup. And let's have a look at the result. So here are the results. That's the path tracing render, and this is Lumen render. Still, you can see there are a few things which are different compared to Lumen and path tracing. So in path tracing, this looks much better, this shadow, and overall, like fidelity, maybe the quality of the glass or details are better. But when we set up the scene really nicely, that looks really good even in Lumen. Just like this one actually is without ray tracing. There's no ray tracing for the glass. It's still using high quality reflections for glass, but it's looking better in path tracing. And also you can see that in path tracing there is some better occlusion, which like basically makes this area darker, which is more realistic because there's just something covering it. And the fidelity of the motion blur, it just straight up looks like a photo, right? But if you zoom here, this one too looks like a photo. So there's just like a tiny difference in the details between path tracing and ray tracing and the Lumen. As I said, the second bounce in the glass really matters. So for example, here there's no second bounce on the chrome, which is inside the glass. But here in path tracing, we can see that there is something also bounce in the light, which is our chrome material under the glass, right? So this one is really cool and just a tiny little bit better. But still, you can get really amazing results even with Lumen, and that looks pretty cool. And in the next part, where we will set up the production pipeline and like more information with the layers, you will be able to refine this just by yourself, and it will be looking even cooler because you will be able to work separately on each of that of this part of this shot, and you'll be able to use some masks, for example, for adjusting that in Photoshop and making your renders even cooler by basically cheating. For basic setup, this is it. I think the result is really cool, and you really can achieve that even with Lumen.